In this video, we're going to talk about matrix multiplication. Now, to form the product of matrix A times matrix B, the number of columns of matrix A must be equal to the number of rows on matrix B. So in this case, any row of A has the same number of entries as any column of B. Each entry of the product is obtained by summing the products of the entries of a row of A by the corresponding entries of a column of B. You'll see this when we get into actually multiplying these. So we have our algebraic definition here. Let matrix A be an n by r matrix and matrix B be an r by n matrix. The product AB is the n by n matrix where C sub ij is equal to A sub 1, B sub ij, plus all those other numbers there. It's really not too hard once you understand the pattern. Now, the key to understanding how to form the product of any two matrices is to first consider the product of a 1 by r matrix A with an r by 1 matrix B. Now, according to the definition, you're going to get a 1 by 1 matrix. So when we look at this example here, the product of AB is a 1 by 3, so 1 row by 3 columns, matrix A, and a 3 row by 1 column matrix B, where A is 1, 2, 3, and B is matrix 4, 5, 6 there. So really, we're going to take the 1 by 4 plus the 2 by 5 plus the 3 times 6. So when we simplify what's inside that matrix there, you're going to get 4 plus 10 plus 18, which does give you 32. Now then the ij entry of the product AB of an n by r matrix with an r by n matrix is going to be the product of the ith row of A, with, depending on how many rows you have, with the jth column of B, as illustrated in example 4 here. Now, we start off with a 2 by 3 by 3 by 2. So this is a 2 by 3 matrix. This is a 3 by 2 matrix. Our answer then will actually be a 2 by 2 matrix. Now remember, you can only multiply these if lined up, these two middle numbers are exactly the same. If they're not the same, you can't multiply. But in this case here, because they are the same, you can multiply these. So here we go. We're going to take the top row times the left column. So we'll have 2 by 1 plus 1 times 0 plus negative 3 times 1. So there's our top left entry. Our top right entry will be the top row times the right column. So we'll have 2 times negative 4 plus 1 times 2 plus negative 3 times 0. Our bottom left entry will be the bottom row and the left column. So I have 0 times 1 plus 1 times 0 plus 2 times 1. Our bottom right entry will be the bottom row and the right column. So take 0 times the negative 4 plus 1 times 2 plus 2 times 0. Now you should notice some patterns even in the matrix itself, in the work. You can see that we have a 1 and a 1 here, 0 and a 0 here, 1 and a 1 here. It'll be the same part on the other matrix, on the other side of the matrix. Now when we simplify this, I'll try and color code it here too. 2 plus 0 plus negative 3 does give you negative 1. Moving to the red part, negative 8 plus 2 plus 0 is negative 6. Moving on to the bottom left, 0 plus 0 plus 2 is 2. Moving on to the black, 0 plus 2 plus 0 is 2. So here is your product A, B. Now, don't expect to get this on the first try. It's going to take some extra time to practice. Now, to find matrix AB in the second part here, really what we're going to be doing, we're going to take 2 times 1. So our first row times our first column. Again, we can multiply these because the number of columns in matrix A is equal to the number of rows in matrix B, plus 0 times negative 3 plus 1 times negative 2. Top right, we'll have 2 times 2 plus 0 times 1 plus 1 times negative 2. Bottom left, we'll have 1 times 1 plus 4 times negative 3 plus negative 3 times 0. And the bottom right, take the bottom row and the right column, 1 times 2 plus 4 times 1 plus a negative 3 times a negative 2. So when we simplify this, what we'll have, 2 plus 0 plus negative 2, which is actually 0. 4 plus 0 plus negative 2, which is 2. 1 plus a negative 12 plus 0 is a negative 11. And 2 plus 4 plus 6, 2 plus 4 is 6, plus 6 would be 12. So here is your product of matrix A and B. Now, if you should have any questions, please come in and ask me. Now, you're probably asking me, Mr. Gordon, can we do these in our calculator somehow? The answer is yes. Now, in example 5, we're going to use matrix multiplication. If you notice in matrix B, there are some decimals because we're talking about money. So Florence makes 3 different cut flower arrangements for Mother's Day, each involving roses, carnations, and lilies. Matrix A shows the number of each type of flower used in each arrangement. So in arrangement 1, you're using 5 roses, 6 carnations, 4 lilies. In arrangement 2, using 8 roses, 6 carnations, 3 lilies. In arrangement 3, using 7 roses, 7 carnations, and 3 lilies. Now the florist can buy his flowers from 2 different wholesalers, number 1 and 2. But wants to give all his business to one or the other. He doesn't want to split it down the middle. The cost of the 3 flower types from the 2 wholesalers is shown in matrix B. Now it says, construct a matrix showing the cost of making each of the 3 flower arrangements from flowers supplied by the 2 different wholesalers. So the way we're going to do this, we need to make sure the columns of matrix A will match the rows of matrix B. So that means we're going to have to flip matrix A on its side a little bit. So what we're going to have then, this matrix A will have the 3 different types here, the 3 different arrangements with roses, carnations, and lilies. So we'll have 5, 8, 7 going down, 6, 6, 7, and 4, 3, 3. We're going to multiply this by roses, carnations, lilies, wholesaler 1, and wholesaler 2, $1.50, $1.35, 95 cents, $1, $1.30, and $1.35. The reason we're doing this, in each arrangement, we need the roses to match up with the roses, carnations, carnations, lilies, and lilies. Now, yes, we can put these into our calculator. It's not very difficult. What you do, you press the second button, and X inverse, it gets you the matrices. Now, we need to edit, so scroll over to edit, press enter. Now, our first matrix is a 3 by 3 matrix. It goes 5, 6, 4, 8, 6, 3, 7, 7, 3. We're going to go back to the matrix menu, press edit. I want to go down to B because I'm editing matrix B. Matrix B is a 3 by 2 matrix with $1.50, $1.35, 95 cents, $1, $1.30, and $1.35. Now to multiply these matrices, actually really simple. We're going to go back to the matrix menu, press enter on matrix A. Again, go back to the matrix menu, press enter on matrix B, and we have our answer right there. So I'm going to take a picture of this habit here. So there's our matrix. 1840, 1815, 2160, 2085, 2105, and 2050. So there's how we have it. So these are the flower arrangements. Wholesaler 1 for arrangement 1, it's going to be $18.40. For wholesaler 1 for the second arrangement, it's going to be $21.60. For the third arrangement, it's going to cost $21.05. For wholesaler 2, for the first arrangement, it's going to be $18.15. Second arrangement, $20.85. Third arrangement, $20.50. So there you have it. Here is a applicable use of multiplying matrices.